Oh yeah, I think that happened last year as well.
You've been the tallest speaker ever in AppSec.
Oh, that's probably right. Probably right. It's not my best feature.
Why is he got to draw?
There's another Jeff Williams that works for Microsoft. Almost my name. There used to be one that worked for Microsoft. We're invading. Jeff Williams is the world.
We need to take off the U.
I put it up there.
Okay. Smile.
Okay.
Yeah, so this is making sure from the back of the studio.
Right.
So it's also the 70. Got it, OWASP. Yeah.
Need a little more light.
They're talking about it. You guys want.
We're gonna wait just a second. Michelle, start.
Here's like another minute.
Okay.
I want to listen to you talk, so I can go 50 years.
Literally shoot the other speakers. A lot to talk about. Got time for this. He said, wait a minute, he's got to go shoot the other speakers. All set? Okay. All right, we're going to get started. Hi, my name is Jeff Williams. I'm the CTO and founder of Contrast Security. You may have seen us down there on the vendor booth area. I was also a founder at OWASP. I've done a lot of projects. I've invested a lot of time here. I want to thank all of you for everything you're doing to contribute to OWASP. I got a lot out of my time at OWASP, and I think it's really great. So today I'm going to talk about why application security experts are really part of the problem. And we'll see how that goes. So I like this, by the way, the sign outside says why the AppSec experts are killing, not killing you. A little different meaning. So I want to start out with a little story about this. This is not a basketball. This is a basketball coach. See, this is the Wilson 9450. Anybody know why it's called 9450?
94 sensors.
Basketball court's 94 feet by 50 feet. So this is a sensor basketball. It's got a whole bunch of sensors inside it. It measures how hard you dribble. It measures the arc of your shot. It measures how fast you release. Whole bunch of stuff. And it's actually an amazing way of learning about your game. So I've been playing basketball for like 30 years, and I learned a lot about my game. See, this thing has a model inside it of what good basketball play looks like. And turns out your arc of your shot is supposed to be about 45 degrees here, I think, right in here. And you can see most of my shots here are shooting flat. I did not know that. And actually, I started thinking about it, and I actually think it helped my game when I started playing with this. And all you have to do is play with this basketball, and you get when you're connected to your phone, it gives you like all these dashboards, and it actually even gives you like exercises to practice, and it measures your time and so on. It's actually pretty amazing. What I get from this, from an AppSec perspective, is that there's this model here. There's this approach to teaching basketball. There's a model that's built into this 9450 that says what good basketball looks like. There are sensors that measure how well you do against that model. And then there's these analytics that show you and communicate that to you very clearly. That's a really powerful model for improving at anything. And that's what I'm going to talk about with regard to application security. I think we can learn a lot from this basketball. So we actually, I thought, some of the speakers yesterday did a great job of talking about this. We actually suck at application security. So if you look at the Verizon DBIR report, these are the ways they research breaches, and they check out how did these breaches happen, what was the sort of underlying cause. And if you look at the underlying cause, you can see there's the things we read about in the news, like point-of-sale devices and skimmers and crimeware and even spies and so on. But the biggest cause by far, over 50% bigger than any other category, is application security. But what's crazy is here's how we're spending money. So 1.7% of security spending goes towards AppSec. All the other spending is on perimeter kinds of protection like antivirus and firewall and those sorts of legacy technologies. This is crazy, right? This is like locking all the windows in your house or leaving the front door wide open. Okay? Now, it makes sense to me that this is how the world is because our solutions in application security are pretty terrible. They're complex and they don't really provide a lot of value. So I've done work for the last 15 years with major financial organizations and government agencies on their AppSec programs, and at the end of the day, I've got 3 metrics. I want to try to summarize the output of those programs. So in terms of assurance, those programs are not doing very well. On average, organizations are producing applications with 22.4 serious vulnerabilities in them. That's a lot. Imagine flying on an airplane if it had 22.4 serious safety problems. That would be nuts. But in AppSec, that's what's out there. In terms of coverage, it's terrible. In most organizations, they're only doing application security work on 10% of their application portfolio. The other 90% doesn't get any work. So again, with the airplane analogy, imagine if the planes that you check have 22.4 serious vulnerabilities, but you're not checking 90% of the fleet. Yikes. I don't know if I'd fly on that airline. And in terms of vulnerability coverage, we're doing really pretty badly. We check the obvious things, some of the OWASP top 10, but some of them are pretty hard. Like access control is massively overlooked in most reviews. You can't really scan for it, despite what some vendors will say. It's complex. You got to get in there and verify this. And so we're not covering the things that are really actually pretty important. And then in terms of process fit, my barometer here is set to mad. AppSec irritates everyone. Anybody been in a situation where the development guys weren't really super respectful of the security guys, and vice versa? Yeah, that's terrible. So we're not providing great value, and we're pissing everybody off while we're doing it. That's not a recipe for success. So I want to try to address those core problems and give you some ideas about how we might do application security differently. So here's my picture of a traditional application security program, and you can see on the left all these little arrows. Those represent development projects. They're running through time, okay? And we've got an expert application security group set up in these traditional legacy application security programs, and that group uses expert tools like static analysis and dynamic scanners and things like that. I call them expert tools because, frankly, you really do have to be an expert to run those tools effectively, tailor them for the application that you're scanning, and to read the results and know that certain things are false alarms and that certain things aren't. You've got to be an expert. So we've got this inherent bottleneck built into this process. And this is why these teams are feeling really squeezed, right? Every year there's more and more applications to look at, and these teams have to continually sort of cut their level of rigor in order to try to get through the whole application portfolio. That's why they're not doing the whole application portfolio. They're really only looking at the critical 10%. And they're sort of squeezing the things that they're looking at. I was at a major insurance organization, and I was talking to them. Their program is they check for two things. They check for, is every piece of input validated? And are they doing prepared statements? That's all their whole review. They throw out every other piece of data that they collect from static analysis and everything. That's the only thing that's making it through this. It's crazy. So another trend that you'll see is some people are starting to talk about lightweight application security tools. Any tool that you see that says lightweight is complete bullshit. Those tools, that just means they're not checking all the important stuff. They're just skimming over the top and finding the things that are easy for the tool to find. It's crap. So this is where all my clients are 5 years ago. And development organizations interpret delays as damage, and they route around them. Like, we are scientifically setting ourselves up as a roadblock, and development teams are just trying to get around us. So we've got a cultural problem, a process problem. So I started on my road to a different way of doing AppSec 5 years ago. I did a talk at Black Hat, and I was studying something totally different. I was studying what I call Java Enterprise Rootkits, where I was looking at what could a malicious developer really do bad inside an organization. How would they Trojan put a backdoor into an application? How would they hide it? And I found all these good techniques for hiding malicious code, and I wanted to start studying those things. But along the way, I found the holy grail of backdoors called the Java Instrumentation API. Has anybody played around with it? It's excellent, right? It allows you to modify a running Java application all in memory. Change the code however you want while the application's running. Really cool. So if you're a bad guy, that's great, right? You can insert your Trojan, let it run, steal all the data, do whatever you want, and then pull that code out, all in memory, so that it never existed anywhere on disk, and you can track it. But I thought, while I was doing this, I thought, God, there's got to be something good we can do with this instrumentation API. So let me tell you how the instrumentation API works, actually. So in Java, it works similarly in .NET and other languages, but let's just stick to Java for now. So when you launch Java, you attach the agent. Super simple. It's just like adding a memory option to the JVM. There's even a way of doing this programmatically in Java 1.6+. But here we're adding the agent to our config. And what that does is it says we're going to call this pre-main method in agent.jar. That's it. So in that pre-main method, you can add a class file transformer that intercepts the bytecode that's normally being loaded by the class loader. And you're basically hooking the class loader. You're getting the bytes here, and you can modify those bytes. So you need to parse them with something like ASM or bcell or something. Parse them. You can add code, you can change code, you can delete things. It's not perfect. You can't do just any transformation you want. There's a little restriction. But you can change them up, and then you can push those bytes into the class loader, and then what gets loaded into the JVM is modified classes, instrumented for security now, okay? So this happens very quickly when the JVM starts up. You can modify all the classes, you can instrument it. Now, most people use this for logging, which is really boring, right? We're going to add a little bit of logging to our applications, okay, whoop-de-doo. But you can use this for really interesting stuff. So we can actually see what's going on inside a running application. Any of you guys ever done a pen test and a code review at the same time? You're looking at the code, and you switch over and you're hacking on something, and you're checking the code, like, wow, that didn't work the way I thought it was going to work, and you switch back and forth. The reason that you do that is, and it's super powerful, by the way, if you're doing pen testing without the code, or code review without the pen test, you're crazy. But the reason that's so powerful is because you're getting a picture of what's going on inside the running application. Like you've got more context in order to make decisions. Well, instrumentation can give you all of that context, right? So you can see the HTTP request, you can see method calls as they happen, you can see all the runtime data, the parameters that are going in and out of all those method calls. You can view them and introspect them. You can see all the libraries and frameworks and platform runtime jars. You can see everything that's going on, even back-end connections as they happen, and all the data that's going back and forth through those back-end connections. And it's an incredible amount of visibility that you can get into an application, and it's totally passive. Or you can do it so that it's totally passive. You're not modifying the way the application works. And you don't have to change the application at all. This can all be done at runtime. So we don't have to affect your development process, your development tool chain, your build process, your deployment process, your testing process. None of that has to change. You just build the code the way you want and deploy with an agent. Now you can put this agent in any environment where the application is running. You can put it into development, you can put it into test, you can put it into staging or QA. You could even put it into prod if you want to monitor the application. And I thought Gene Kim made a really nice point. If you don't know Gene Kim, you should get his book, The Phoenix Project, and check it out, or Visible DevOps Handbook. They're great stuff. He said if you have code that's important enough to deploy, it's important enough to instrument it. And I think he's really onto something here. The future of applications is being instrumented all the time. We need to monitor our applications to make sure that they're doing the right stuff, and we need to do this for security. We need to monitor what's going on inside our applications all the time. So let's imagine that we've got all that data, all this visibility into what's going on in the application. Now, how do we use that to find vulnerabilities? Okay, first you've got to realize a vulnerability is not a line of code. A vulnerability is a pattern of events within a running application. Okay, so imagine a SQL injection. Right? It's a pattern of events. A SQL injection, by definition, is untrusted data coming into your application, flowing around, and getting concatenated into a SQL query that then gets sent to the database and executed, without having gone through some kind of proper encoding or validation. Right? That's a SQL injection as a pattern. And so in this application, maybe this is a Spring app, and maybe we've got a Spring controller over here, or a web service where data's coming in. Maybe the application pulls the data out of the web service, sticks it into a Java bean, puts it in session. Later on, it gets into the business function, and it pulls that data out, concatenates it into, or sends it to the data layer, concatenates it into a SQL query, and sends that off to the database. That's a SQL injection. And you don't have to exploit it to prove that it's a SQL injection. It's by definition, it's a SQL injection. So we can monitor not attack traffic, but normal application use and identify vulnerabilities very clearly. But here's another example. It would be a stored cross-site scripting, right? We can say, here's some data. It comes out of the database, and it bounces around through the application. It gets pulled out of some data bean into a JSP and sent to the browser without proper encoding. That's cross-site scripting. So you can see, you can find these vulnerabilities by using rules against our instrumented data and do a very good job of identifying a broad range of vulnerabilities and doing it very accurately. Now, it's not limited to just these data flow kinds of vulnerabilities. We can analyze the HTTP response, like right when the data leaves the application here, we can analyze the HTTP response and see, does the output have the proper headers? Now, did we set the extra options header? Did we set the caching headers? Did our forms have a target so we don't have parameter pollution? all sorts of attacks we can identify in the HTTP traffic. We can also analyze the libraries here. We can see if they have known vulnerabilities, that's A9 and the OWASP top 10. We can check their versions and see whether they're secure enough. So having insight into what's going on inside the running application, critical to identifying vulnerabilities accurately. So this is a different approach than static analysis or dynamic analysis. It's really a runtime approach, and it's just, it's very powerful. So I want to give you another analogy to help you understand really how this works. So imagine that your application and your data is sort of this set of islands surrounded and intertwined in a coral reef. The coral reef is protecting all your data and your applications and your functions and so on. So you want to know whether you're fully protected. Well, if you wanted to, you could go and you could check every inch of this coral reef all the way around, all the way through, and everywhere through this island and see if there's any passages that would allow an attacker to get to data that they weren't authorized for, or to invoke a function they weren't authorized for. It'd be a lot of work, it'd be really hard. Or you could instrument the fish. You could put a GoPro camera on all the fish, and if any fish came from out in the deep blue ocean and made it in here and made it to your sensitive data, you could grab their GoPro camera and look at the video that they collected, and you can see how they did it. You see all the steps along the way. And that's kind of how instrumentation works. Okay, you can actually see these attacks, see these vulnerabilities, and detect them without having to attack them, actually, because the fish did it for you, right? So you can get, it's a distributed parallel kind of approach. You get lots of coverage really fast this way. All right, so I want to give you an example of how this works. So this is what we call contrast for Eclipse. This is a totally free Eclipse plugin that uses this instrumentation technique to find vulnerabilities in running applications. And I've got slides here. You can install it. I'm going to do a live demo because it's much more fun. Right? So you can install it really easily. You just pull down the Eclipse menu, go to the Eclipse Marketplace, type in contrast, and hit install. And 30 seconds later, you've got this plugin and you're ready to go. So I've done that already, and I've got it running here. And I'm going to do a crazy demo. I'm just going to create a whole new app in like 30 seconds to demonstrate how this works. I'm going to create a dynamic web project. You can see down here I've got the Contrast for Eclipse plugin. And I'm just going to, let's just name this test. And you can see I've got the Contrast for Eclipse plugin here. It's not doing anything now because it only works when you run the application. So I'm just going to create a JSP here. And we'll call this foobar JSP. And got some data here. I'll do a little code. Just going to put in a little code block. I'll do string. I'm going to get a request parameter here. String name equals request. Okay, parameter name. And we'll concatenate that. We'll do string message equals hello. What's name? Now we can do a whole bunch of other transformations here in the code. I'll just leave it at that for now. And we'll just get down here, we'll put bold message, right? So just a simple little JSP. So all I'm going to do is, to run this with contrast, all you do is you go to your server, and instead of hitting start, now you hit start with contrast. Right? So it's just that easy. And what contrast does is, contrast for Eclipse does here is, as the application starts, it instruments all the code. So it takes 5 seconds or something to instrument the code as it loads, and then we're up and running with the application. So now I can go to my web browser, I'll create test, foobar.jsp. Hopefully this, what did I do wrong? Anybody? I don't look like that started pretty right. I test this like 5 times to make sure it works. Project code test. Just fix it. Okay, that went awesome. So fortunately, I've got another application here. I'm going to figure that out and fix that in a second. So here's an application that I've got. It's called Ticketbook. It's got a bunch of vulnerabilities in it. And I'll put in name, Chicago, credit card. And so Contrast is, when I submit this, Contrast is going to monitor this request and identify vulnerabilities in that request. And they're identified pretty much in real time, so you can see them come in immediately as I use that. That's because Contrast is analyzing that whole path, finding vulnerabilities and reporting them back. So you can see there's a SQL injection flaw in this. I can double click on that, go right to the line of code, and I get this trace. And I wanted to show you the trace. I'm going to make this full screen for a second. I want to show you this trace. This is really important. So Contrast sees every step along the way. This is the request I get parameter call. You can see it says Jeff Williams, and you can see it creates a SQL query, including that Jeff Williams. Here's another piece of it, the city part, Chicago, and you can see this is where it appends Chicago onto the query, and it finishes the query, and then this is the line of code where it executes that query. So it's an incredibly detailed trace of, it's really the GoPro camera version of SQL injection as viewed from the point of view of the fish, right? It's very easy for developers to see this and know what to do about it. We give them, Contrast for Eclipse provides a summary of what that problem is. It gives them all the stack traces for each of the events, so you can actually review the whole stack if you're interested. You have the whole HTTP request here. This is a lot different than static tools, right? Static tools can't show you the HTTP request. They don't give you a test case. So any of you that have ever been involved in reviewing static analysis findings, you probably know it's a huge pain to track down where that actually is in the code. Wait, over there. Huge pain to track down static analysis tools and figure out where the exploit actually is, like what URL you would go to make that code go, and vice versa, right? If you've got dynamic findings, you don't know where to find them in the code. So Contrast, we've got them both together here. You've got all the information that you'd really need. So Contrast for Eclipse is it's a really powerful way of finding vulnerabilities in a way that's compatible with the way people write software, right? So this is not, doesn't require any extra steps for anyone doing their development. Let me show you a couple other vulnerabilities here. So I wanted to show you this an XXE vulnerability here. Anybody played around with XML external entities before? It's a fantastic vulnerability. It's in most XML parsers, and it allows the attacker to really exploit the XML parser that's in your servers and make it do things that it really wasn't intended to do, like go fetch some data. So here, you wouldn't have to exploit this to find the problem, but I've actually put the exploit in here. So when I hit go, you can see that I tricked the XML parser into actually serving up my password file. And Contrast for Eclipse identified that right away. It said, hey, you've got a XML external entity problem. Here's the line of code. And from a workflow perspective, this is really easy. If I go to the recommendation, it says here, add these two lines to turn off dot type parsing. And so I've got that in my code here, and I can just save that. I can delete that finding, try the lesson again, hit go, and this time it won't find it, right? Because I've protected myself against XML external entities. So it's a very natural way for developers to work, getting these error messages right in their IDE in the way they're used to. I wanted to show one other finding here. There's an insecure hash algorithm finding here. And I double-clicked on it, and it took me to this line of code. And I know that's a little small. Can anybody tell me what that line of code is doing? It says driver manager.get connection, JDBC, :HSQLDB, blah, blah, blah. This is a line of code that's getting the driver manager for HSQLDB database, right? It's a JDBC driver. Why does Contrast report an insecure hash algorithm on this line? There's no call to MD5 here. What's going on?
It knows you're sending it unencrypted password.
Say again?
It knows you're sending it an unencrypted password.
It actually doesn't. You're closer. That call to MD5 is buried deep inside HSQLDB library, but it doesn't really help people to report that line of code buried somewhere in HSQLDB, right? So we report the line of code that is in your program. This is what you can control. So we've analyzed the stack, and we can see, if I look into this, here's the stack trace. I'll make this big. Here's the stack trace, and you can see this is all HSQLDB code in the library, and way down here, there's actually, it's in a method called user.setPassword. So we're actually taking that password and we're MD5 hashing it and using that for something security related. Now I haven't done the code review on this, but it doesn't look super secure to me. But you can see the important thing is that they know that that's happening deep inside their application. So Contrast for Eclipse doesn't just analyze the custom code, it analyzes the whole application, including all the threads that cross over from your code down into your libraries and in your frameworks. It doesn't care about reflection or inversion of control or any of the patterns that make static analysis so hard. It just analyzes the code that runs to see if it's got any vulnerabilities in it. Any questions? I know that was a lot. Yeah?
What kind of overheads does this give on a running application?
Yeah, there's a little bit of overhead. So on WebGoat, for instance, Contrast adds about 5 milliseconds to a round-trip request. So you're never going to notice it in dev or staging or test, but in a production environment, if it's under heavy load, you might notice. So it really depends on how you want to use it. There is a slight penalty. Any other questions? Yeah.
So you guys have to actually exercise the code to get the visibility?
Yeah.
Have you thought about ways of not buzzing it or running it with some input?
Sure.
And spider it or something?
Yeah, there are a lot of tools that will exercise your code. You can use JUnit tests or Selenium tests. You can use a spider. Even we have a lot of people that use dynamic scanners to exercise their application, and they don't care about the vulnerability results. They just really care about the spider.
So that's a recommended approach, so use contracts and then some other tool that will try to exercise or get code coverage.
Some organizations are already doing a pretty good job on code coverage. So for them, I would say just keep doing what you're doing. If you don't have code coverage from some other way, then you probably want to do something to simulate that.
So one of the things we did a POC, not on this, but on the actual Contrast product. And so what we did is we put in all of the QA testing and all of that actually exercises. So we just have the testing that happens that utilizes this as it sits on the app servers. So instead of having a separate security testing, our QA and functional testing, all the unit testing, everything that they do, just from a performance standpoint, a regular functionality standpoint, exercises all of it, and we get the results from that. That's the way we kind of deal with that.
And is there any mechanism to show, in the tool itself, code coverage?
We had that as part of the tool. We could measure exactly how much code coverage, but it adds a little performance hit to do that because you got to measure every method call. So we think it's better to let you use the code coverage tool that you have. I think you could use Jacoco or ECLEMA or any of the other coverage tools to measure your coverage. Maybe you do that a few times to make sure your test suite has got pretty good coverage, and then you don't have to run that every single time. It's interesting, we looked a lot into coverage, and dynamic tools, if you actually hook up a code coverage tool when you run a dynamic scan, you're going to hate yourself because they get terrible coverage, like 25, 30% of the code. Even when you don't consider all the libraries, they don't exercise the libraries nearly enough. And surprisingly, static tools don't get great code coverage either. You'd think that they would get sort of 100% of the code, but they don't cover any of the libraries or frameworks or the jar file code. So that means they have all these paths that sort of stop their analysis, and they don't know what happens inside those libraries. So that contributes to a lot of the false alarms that they have. They also don't exercise all the code paths. It's just too hard for them to really understand all the entry points and all the ways of making the code go. So not great coverage there. That's certainly a challenge. That's why I actually like the way Contrast does it, because you can measure it, and you can actually know how much coverage you're actually getting. Any other questions?
Does it work with other languages, like Ruby or Scala?
So I'm just going to talk about the free Contrast for Eclipse here, but if you want to come down to the booth, we can talk about other languages. Yeah, we're trying to do something good here for the world. Like, get this tool to developers. It's free. It's way better than anything that's ever been free on the market before. So we're trying to get this out there because SQL injection has to stop. It's just way too long. We've known about it for 15, 20 years, and we're not really making a lot of progress against it except by accident. We got to do much better against these flaws. So we're trying to, push the market along. So hopefully you guys can help me. You can get this to developers. Send them a link, encourage them to try it and use it. Tell them it's not like those other security tools that are going to piss them off, but something that they can actually have fun with and find vulnerabilities really accurately. Okay, so I'm practical though, right? I know that this is just a tool, and a tool isn't a a whole application security program. So I wanted to talk about, oh yeah, go ahead.
So just one last question. Does it expose an API or anything, or using it programmatically?
So it is possible. It's possible to create custom rules that Contrast can enforce. In fact, like the Contrast engine is really just a platform for checking program behavior against patterns, right? So it's like behavioral analysis. So you can define a pattern of execution that you want to flag and tell Contrast how to look for it, and then it can find it. It's a little advanced though, but there's an XML format for custom rules. And in theory, you could get the output and also do stuff with that as well. Yeah. So actually, I'm a huge fan of what I call positive rules. Most of the rules that come with your security tools are negative rules. They model bad program behavior. But I'm a huge fan of making positive rules, modeling good behavior, like every one of our Spring controllers needs to call this access control method. That's a cool, positive rule that you can put in your application, and it's very effective, won't false alarm ever, and so I think it's a good approach. Eventually, I'd like to see the market shift towards getting people to articulate those positive rules. I'm going to share a little bit more about that in just a second. So, I want to zoom way out here and think about okay, so what is the problem that AppSec is trying to solve? And I want you to think about, your organization as a black box. It's a factory and it produces software. Okay, now AppSec's role in this is to help those organizations produce code that doesn't have glaring vulnerabilities, right? It should be secure. However we want to define that. So, these software factories come in a lot of different shapes and sizes. There are small shops, there's agile shops, waterfall shops, there's huge software shops. They can all produce secure code, but they're very, very different. And I think, sort of the approach of trying to compare different, the way that different organizations do application security is crazy. It's silly. It's like trying to say, Dunkin' Donuts is a kitchen the same way the Four Seasons is a kitchen, and say, oh, let's look at the practices that are common to them, and we'll come up with a maturity model for kitchens. Well, that's just dumb. There's not going to be any overlap there, right? But both of those models are great. They can both have great business and do great things. So what we want to focus on is what actually matters here. What matters is that this process produces code that's arguably secure. So let's look at how we go about generating that. What's important is the output here, not sort of the how. So you've heard of continuous integration and continuous delivery using core DevOps practices. I want to introduce the idea of continuous security, continuous application security. And I define that like this. I said, if you're doing application security continuously, it means you're capturing and sharing and challenging and improving and verifying your expected security model as part of the normal engineering process, okay? And with security experts as coaches and toolsmiths only. So remember that bottleneck. If the security experts are in the critical path for building software securely, then they're a bottleneck and they're going to kill your culture. So you got to get them out of the critical path. And I think we can do that with this instrumentation approach. So here's how that goes. So from the 9450, expected security model, sensors, analytics. This is the core, continuous application security. So the expected security model, how are you doing on time, by the way? I want to make sure I don't go this. Okay. So I have 20 minutes? Perfect. Okay, so here's the expected security model. We're going to talk about that. Then we'll talk a little bit about sensors and a little bit about analytics. So the first thing I want you to realize is that security is a thing. It's something that you build. It's a tangible, real thing. It's not this mystical, crazy property of software that you can't ever touch or feel. It feels like that though, right? Like if you build something and it's got security in it, you can't touch the security, you can't feel the security, right? It's just in there. I want you to change that line of thinking. I want you to think about security as a thing that you actually build. And what it is really is what we're trying to build is confidence that the right security defenses are in place, that they're working correctly, and that they're used properly. Now the important thing is if you can't share that confidence with someone else, then it really doesn't matter, right? You can be over in the corner, happy that your application is secure, but nobody else is going to know it. Your management's not going to know it, your customers aren't going to know it, your engineering team's not going to know it, so it doesn't matter, it doesn't really exist. We have to make this tangible. We have to turn security into a thing. So how do we do that? What does it look like? This is Apple Pay's security story, right? I think this is actually pretty cool. They've put out a whole bunch of details about how Apple Pay works. And you go read about it, and it's cool. It's got a whole bunch of stuff in there that says, you know, we're going to have tokens, and we're going to use this secure form of NFC, and all this stuff. Now, a lot of people read this, and they go, well, Apple Pay is going to be super secure. But I don't. I read this, and I see a bunch of claims, right? And I want you to read critically. This is actually, to me, this is a test plan. This is a bunch of stuff that needs to be verified. I think it's great. So this is still cool, right? This is very awesome that they wrote down what the security mechanisms are supposed to be, but they still got to prove to me that they're there somehow. But I encourage you to do this in your organization, is make your security story explicit. Let everyone in the development team know about this, and I want to call out David Rook, who was talk yesterday, he's right there in the room, from Riot Games. He talked about the RFC process that they have in their organization. So they've got RFCs at various levels of scale. Some are enterprise RFCs, some are application RFCs, but they define how security is supposed to work. And it's a collaborative process. They've got people that can, it's a request for comment. It means that people can comment on it and improve it. And their security team has put out RFCs that say, hey, we should do encryption this way. And the team comes back and goes like, you know what? Oh, actually, you told me a story about secure pointers. Right? You say, hey, we're going to do secure pointers this way because of this new cool library. The engineering team came back and said, no, we're not doing that. We do secure pointers this way, and it's working for us, and we're not going to change it. And so that's awesome, right? That's great collaboration so that you get to the right answer on what the security features are supposed to be. And then, Dave and I had a nice conversation about putting in sensors to verify this expected security model, right? Getting the expected security model right is great. That's good work. People do that. Some people call it threat modeling or architecture review or whatever they call it. Get that expected model right. Then you got to build the sensors to actually verify this in real time. So here's a little example of one. You can see, I call these defense strategies. Things like, we're not going to allow injection. You want to say how you're going to do that, right? You have this strategy for not allowing any kind of injection. So you're going to do strict positive validation, use parameterized interfaces, make sure all your parsers are hardened so you don't have things like XXE, use Hibernate, database abstraction layers instead of going directly to SQL. Things like that, you have a strategy. And it's actually, I want you guys to start on building your expected security model. The best way to start is to go ahead and look at what security mechanisms you already have in place and start writing them down. And you may come across some things you're like, well, why do we have that? Why do we have this encryption module here? And most likely, there's a good reason for it. If you bubble it all the way up to the top, you'll get to like these broad security goals and even up to business goals. So your security story evolves over time, just like David's RFC process. Security story evolves. And I think it's actually really important to do this in an open way. I would encourage everyone to not only make it open internally to your organization, but actually even think about exposing this externally, like Apple's done. Because it communicates really clearly how important security is to your enterprise. And there's nothing in there that an attacker couldn't figure out if they wanted to, right? Like all of these things, an attacker could probably generate test cases to verify those things. So you're not disclosing anything. What you're doing is you're setting your organization's direction. You ever heard, Good to Great, the Jim Collins book about building companies? He says you got to get everybody pointing the same direction. You just get all those flywheels turning the same direction, and you can do really great things. So it's like that. Making it open helps to do that. Okay, so that's the expected security model. Got to get straight on that. That's what defines security for your organization. The next thing is you got to build some sensors. And I don't have time to do a whole talk on sensors, but I did one last year here about, it's called Application Security DevOps Speed and Portfolio Scale. And it talks about how you can take simple tools, open source tools, free tools, custom tools, and turn them into sensors that report continuously. And so when I say an AppSec sensor, I mean a tool like the tools that you've been running, but instead of running it just once, at the end of the life cycle, or every once in a while, these tools run continuously. A good example I gave was the OWASP dependency check tool. This is something you need to be running all the time, because new vulnerabilities are discovered in your libraries all the time. So what you want is, instead of every time a new vulnerability comes out, you have to go do a scan of everything in your whole enterprise. Anybody do that for Heartbleed? Yeah. Was it pain? Yeah, massive pain, right? Wouldn't it be great if you knew where all your libraries are? They should all be reporting back to you. That's how sensors work, right? They're monitoring everything and gathering the data that you need, so when there's a problem, you can just say, oh, well, I need to go find out where we're running OpenSSL and talk to the 12 places in your company that are running a vulnerable version and update, right? Much, much faster reaction time. So, this other talk was about building an application security sensor network. And if you've got a bunch of sensors, you want them to run across your whole portfolio all the time. All the data should be pouring in. And to do that, to manage a sensor network, you're going to have some infrastructure. I built one for this talk using Puppet, where we pushed out tools, got the data back, we ran all the output from the tools through what I call the digester to create a canonical form, and we built a nice dashboard out of this so that, always running. Really powerful approach to AppSec, I think. So then the last piece, right, so we talked about the expected security model, we talked about the sensors, and the last piece is really communicating what we found to people. We call it analytics here. I think the age of the security report in PDF is over. And we can't report vulnerabilities in PDF files anymore because it's just way too slow. So imagine when you run a static analysis tool and you get a PDF file that's 700 pages long, and now you have to go through that, weed out the false positives, figure out which vulnerability goes to which developer. It's an extremely time-consuming, expensive process. We need this thing to be much more like dashboards and alerts. So I wanted to give you a picture of a couple. This is Yelp's CSP dashboard. This is their content security policy. So Yelp uses CSP to stop XSS attacks and a few other things. And CSP has the ability to report back violations from the browser. So Yelp has this, they're getting thousands of reports every minute from all the people that are browsing Yelp all the time. And this allows them to very easily see problems that they got to go fix. So this is, so one example of how continuous application security is different than a pile of PDF reports. Funny story, I was in a CISO's office in a major financial organization, and I was talking to him about how do you do AppSec. He said, well, we do pen tests, and we get the reports. And so, what happens with all the findings in those reports? Are they all fixed? He goes, I don't know. And I goes, well, what happens to the report downstream? Like, well, we send a copy down to the developers, and hopefully they fix that stuff. I was like, don't you have, is there a database of these things where you're tracking them? He goes, yeah, it's right here. And he pulled back the door. He had a bookshelf filled from top to bottom. Every shelf was full of penetration test reports for years and years of vulnerabilities in there. So we got to get away from that, right? We need to have real analytics. This is Etsy's security dashboards. They monitor a whole bunch of different things. But what's cool is they make these dashboards public for everyone in the company. And I like this. They said, thank you. Thank you for doing testing. They're really trying to enable security or developers to do their own security by making it super visible, right? Does security really have to be involved if you've got a sensor that detects an out-of-date library that developers need to update because it's got a known vulnerability in it? I don't think security has to be involved there, right? We can just get out of the way. Put the sensors in place, we got the expected security model, put the sensors in place, get the analytics, and drive this all automatically and continuously. All right, so I think we actually need to go through and refactor AppSec to be more like DevOps, okay? Right now, we've got activities like penetration testing. So to me, penetration testing is really, if you ask these questions that are in red here, there are a number of different aspects of a pen test. The first thing you do when you do a pen test is you work out, well, what is the thing supposed to do? Right? You have to figure out, what are the access control rules? What would a bypass look like? That's really figuring out what the expected security model is. Right? We should actually know that already. That should be part of a separate thing. When you do a pen test, you should actually get a list of here's what security is supposed to look like, go verify it. Another big aspect of pen testing is designing experiments. And the really good pen testers think about what they're trying to prove, like think about what they're trying to verify, and they design an experiment to check it. It could be an experiment that involves checking the code for a certain pattern. They might grep some code. It could be an experiment that involves actually using burp and generating some requests to verify how the application behaves under certain conditions. But they design an experiment that's fast and simple. Sometimes it involves building custom tools to validate this. I've written a number of these for access control systems where I don't want to go through and check every access control check one time and then be done. I want to write a tool that can do that forever. So I call this a sensor. Automation is the process of turning these experiments into sensors that can run continuously. And then dashboards is really, the pen test version of this would be writing a report, right? Probably writing in Word or in some risk register kind of system. You generate a PDF report. We're going to transform that into real-time dashboards hooked into the dev process, right? Hooked into Jira, hooked into bug trackers, and so on. So this is what I'm talking about, refactoring pen testing. Pen testing shouldn't go away. It should be reinvented as a bunch of different activities. And when I say application security experts are killing you, I actually think that application security experts are really, really important to this process, but we're wasting their time. Any time you spend finding XSS, finding SQL injection, testing things that can be tested this way is wasted. What we need is people to be designing sensors that can do this continuously and automatically forever. And the payback here is huge. In the time that it takes to do one pen test, you can build a ton of sensors that then run continuously from that point forward. And then you never have to pen test those again. Right? So think of your current approach where you're doing 100% pen testing and basically zero sensors. And over time, you start building sensors to test stuff, and you start shifting over to the point where you're at 100% sensors, or maybe 80, if I don't know what the limit is, but you can get a lot of stuff tested with sensors, and you're left with a set of really complicated things that are good to spend expert time on. Perfect. Okay, so at the end of the day, I want you to measure the assurance you're actually generating. Everything else doesn't matter. If you're generating exploits, doesn't matter. At the end of the day, the point is, how much of your expected security model are you actually verifying? Are you checking that those defenses are in place, that those defenses are correct, and that they're used properly everywhere they're supposed to be used? That's what matters, is how much assurance you're generating. And coverage is a part of that. Like how much, you could do a great job on one app and leave the other 900 with basically no assurance. That's crazy. So how much of your app portfolio are you covering? And how well does AppSec really fit into your development culture? I think if people are pissed about AppSec, then they're not going to do it, and this undermines your efforts dramatically. So these are the 3 metrics I want you to focus on. If you're getting assurance and coverage and you're a good process fit and people are happy with you, then you can do a really good job at AppSec. And you don't need a maturity model with 200 practices in it to try to get there. So I do have a takeaway for you guys. I think I have some here. This is the application security, the Continuous Application Security Handbook. I have a few of them up here, and then there's more down at our booth. But, hand a few of these around. It looks like this, and this has a lot more details on how you go about building a program that's designed to be continuous. Essentially, it's what we've talked about, perform continuously, use sensors, focus on whether you're actually achieving assurance. And this is really critical, because there's no experts or gates in the path of secure software development. That's at the core of continuous, that's what we got to achieve. So, happy to discuss your program with you anytime. Please come find me. Don't forget to pick up your handbook and to get a contract for Eclipse plug-in for your developers. So with that, I guess we've got a couple minutes for questions. Thank you. I guess it's lunchtime. All right. Thank you, everyone. Appreciate it. So,